1.3 Section Exercises. A. Verbal. 1. Can the average rate of change of a function be constant? 2. If a function f is increasing on, open parenthesis, a, b, closed parenthesis, and decreasing on, open parenthesis, b, c, closed parenthesis, then what can be said about the local extremum of f, on, open parenthesis, a, c, closed parenthesis? 3. How are the absolute maximum and minimum similar to and different from the local extrema? 4. How does the graph of the absolute value function compare to the graph of the quadratic function, y, equals, x squared, in terms of increasing and decreasing intervals? B. Algebraic. For the following exercises, find the average rate of change of each function on the interval specified for real numbers b or h. 5. F of x equals 4x squared minus 7 on, open square bracket, 1, b, closed square bracket. 6. G of x equals 2x squared minus 9 on, open square bracket, 4, b, closed square bracket. 7. P of x equals 3x plus 4 on, open square bracket, 2 plus h, closed square bracket. 8. K of x equals 4x minus 2 on, open square bracket, 3 plus h, closed square bracket. 9. F of x equals 2x squared plus 1 on, open square bracket, x plus h, closed square bracket. 10. G of x equals 3x squared minus 2 on, open square bracket, x plus h, closed square bracket. 11. A of t equals 1 over t plus 4 on, open square bracket, 9 plus h, closed square bracket. 12. B of x equals 1 over x plus 3 on, open square bracket, 1 plus h, closed square bracket. 13. J of x equals 3x cubed on, open square bracket, 1 plus h, closed square bracket. 14. R of t equals 4t cubed on, open square bracket, 2 plus h, closed square bracket. 15. F of x plus h minus f of x divided by h, given f of x equals 2x squared minus 3x on, open square bracket, x plus h, closed square bracket. C. Graphical. For the following exercises, consider the graph of f, shown in Figure 15. Figure 15. 16. Estimate the average rate of change from x equals 1 to x equals 4. 17. Estimate the average rate of change from x equals 2 to x equals 5. For the following exercises, use the graph of each function to estimate the intervals on which the function is increasing or decreasing. 18. 19. 20. 21. For the following exercises, consider the graph shown in Figure 16. Figure 16. 22. Estimate the intervals where the function is increasing or decreasing. 23. Estimate the points at which the graph of f has a local maximum or local minimum. For the following exercises, consider the graph in Figure 17. Figure 17. 24. If the complete graph of the function is shown, estimate the intervals where the function is increasing or decreasing. 25. If the complete graph of the function is shown, estimate the absolute maximum and absolute minimum. D. Numeric. 26. Table 3 gives the annual sales, in millions of dollars, of a product from 1998 to 2006. What was the average rate of change of annual sales? A. Between 2001 and 2002 and B. Between 2001 and 2004? Table 3. Year. Sales. Millions of dollars. For year 1998, the annual sales was 201 millions. For year 1999, the annual sales was 219 millions. For year 2000, the annual sales was 233 millions. For year 2001, the annual sales was 243 millions. For year 2002, the annual sales was 249 millions. For year 2003, the annual sales was 251 millions. For year 2004, the annual sales was 249 millions. For year 2005, the annual sales was 243 millions. For year 2006, the annual sales was 233 millions. 27. Table 4 gives the population of a town, in thousands, from 2000 to 2008. What was the average rate of change of population? A. Between 2002 and 2004, and B. Between 2002 and 2006? Table 4. Year. Population, thousands. For year 2000, population was 87,000. For year 2001, population was 84,000. For year 2002, population was 83,000. For year 2003, population was 80,000. For year 2004, population was 77,000. For year 2005, population was 76,000. For year 2006, population was 78,000. For year 2007, population was 81,000. For year 2008, population was 85,000. For the following exercises, find the average rate of change of each function on the interval specified. 28. f of x equals x squared on, open square bracket, 1, 5, closed square bracket. 29. h of x equals 5 minus 2x squared on, open square bracket, negative 2, 4, closed square bracket. 30. q of x equals x cubed on, open square bracket, negative 4, 2, closed square bracket. 31. g of x equals 3x cubed minus 1 on, open square bracket, negative 3, 3, closed square bracket. 32. y equals 1 over x on, open square bracket, 1, 3, closed square bracket. 33. p of t equals, open parenthesis, t squared, minus 4, closed parenthesis, multiplied by, open parenthesis, t, plus 1, closed parenthesis, divided by t squared, plus 3, on, open square bracket, negative 3, 1, closed square bracket. 34. k of t equals 6t squared plus 4 over t cubed on, open square bracket, negative 1, 3, closed square bracket. Technology. For the following exercises, use a graphing utility to estimate the local extrema of each function and to estimate the intervals on which the function is increasing and decreasing. 35. f of x equals x to the fourth power minus 4x cubed plus 5. 36. h of x equals x to the fifth power plus 5x to the fourth power plus 10x cubed plus 10x squared minus 1. 37. g of t equals t square root of t plus 3. 38. k of t equals 3t to the power of 2 over 3 minus t. 39. m of x equals x to the fourth power plus 2x cubed minus 12x squared minus 10x plus 4. 40. n of x equals x to the fourth power minus 8x cubed plus 18x squared minus 6x plus 2. f extension. 41. The graph of the function f is shown in Figure 18. Figure 18. Based on the calculator screenshot, the point 1.333, 5.185 is which of the following? A. A relative, local, maximum of the function. B. The vertex of the function. C. The absolute maximum of the function. D. a zero of the function. 42. Let f of x equals 1 over x. Find a number c such that the average rate of change of the function f on the interval, open parenthesis, 1, c, closed parenthesis, is negative 1 over 4. 43. Let f of x equals 1 over x. Find the number b such that the average rate of change of f on the interval, open parenthesis, 2, b, closed parenthesis, is negative 1 over 10. G. Real-world applications. 44. At the start of a trip, the odometer on a car read 21,395. At the end of the trip, 13.5 hours later, the odometer read 22,125. Assume the scale on the odometer is in miles. What is the average speed the car traveled during this trip? 45. A driver of a car Santo PPED at a gas station to fill up his gas tank. He looked at his watch, and the time read exactly 3:40 p.m. At this time, he started pumping gas into the tank. At exactly 3:44, the tank was full and he noticed that he had pumped 10.7 gallons. What is the average rate of flow of the gasoline into the gas tank? 46. Near the surface of the moon, the distance that an object falls is a function of time. It is given by d of t equals 2.6667 t squared, where t is in seconds and d of t is in feet. If an object is dropped from a certain height, find the average velocity of the object from t equals 1 to t equals 2. 47. The graph in figure 19 illustrates the decay of a radioactive substance over t days. Figure 19. Time, days. Amount, milligrams. Use the graph to estimate the average decay rate from t equals 5 to t equals 15.